Hello everyone. For this tutorial video, I'd like to discuss the phenomena of refraction, which is the bending of the light's path. Refraction happens because the light changes speed when it moves from one material to another. You may have often heard that the speed of light is the fastest thing in the known universe, but the speed of light is not as constant as you might have heard, as it will change depending on what it interacts with or passes through. In particular, speed is fastest only through a vacuum or a space with no matter in it, and will be slower passing through any other medium, as it must interact with the atoms and molecules that compose the medium. The index of refraction of a material is defined as the ratio of the speed of light through a vacuum divided by the speed of light through the material you wish to study. And this makes sense based off what we know, namely that the speed of light through a material is lesser than the speed of light through a vacuum. When light interacts with gases, we assume the speed of light through them is so close to it that it is basically exact to the speed of light through a vacuum, as a gas by definition has its molecules so spread apart that it essentially acts like a vacuum for light. Therefore, whenever light slows down or speeds up from changing mediums, it will bend, and this can be demonstrated with solid objects by seeing how when a lawnmower changes speed, as soon as one of its four wheels hits the grass, because of the fact the grass provides more friction than the concrete. The mathematical formula that states exactly how a light would bend when it changes materials is known as Snell's law, which states that the index of refraction at point 1 times the sine of the angle at that point is exactly equal to the index of refraction at point 2 times the sine of the angle at that point. With all the theory out of the way, we can see that a concrete demonstration of refraction is if you were to drop something like a pencil or another solid object in water and observe that the pencil seems to get bent. If you were to look at the point where it enters the surface of the water. And these concrete observations agree with the theory, because if we were to measure angles relative to the point and look up the index of refraction for the air in the atmosphere versus the water, we would see that it follows this formula exactly. And so therefore, if we do not know the index of refraction of a material, we can algebraically manipulate the formula in order to figure it out. In particular, we would state index of refraction of unknown medium equals index of refraction of known medium times the sine of the angle at the point of the known medium divided by the sine of the angle at the point of the unknown medium. And then we would simply plug and play in the numbers and get our answer. Now that I've explained why light changes speeds when it enters through different mediums, I can begin explaining applications of reflection and refraction, starting with total internal reflection within an object, such as how fiber optic cables work. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.